Lesson 1, Module 3, Student Page 2. Consider the sequence that follows as a plus 3. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, plus 3 is 16. Write a formula for the sequence using both AN and FN notation. So A sub n. That means what did we do to get to the next term? Basically, we added 3. If we think about it, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. We're basically just one off each time, so we could say 3 times n plus 1. We could get any term of the sequence by multiplying its position and adding 1. That's an A sub n notation. And if we want to use function notation, the function for the value of n, and we basically are going to get the same thing. We're going to get 3n plus 1, but we have to say where we're going to start, and we're going to start with n equals 1. And that's basically all there is to it, okay? Next question says, does the formula function of n equal 3n minus 1 plus 4 generate the same sequence? Well, let's find out. What is the f of 1? F of 1 is 3 times 1 minus 1 plus 4. That's 3 times 0, which is 0, plus 4. So f of 1 is 4. And that is indeed the first term of our sequence. We don't need to go through all of them, but why don't we try f of 4, which we see up here is 13. Let's see if we can get 13. 3 times 4 minus 1. I'm just putting in 4 for the n both times, plus 4 equals 3 times 3 plus 4, which is 9 plus 4, which is 13. So the f of 4 equals 13. Question asks, why might some people prefer this formula? And the reason why some people might like this formula is because it lets us start off, we can see the first term right from the beginning. We're saying, well, on the first term, we really haven't added 3 yet, so it lets us start with the term we want to find. All right, and the next thing says, graph the sequences in order, the sequence of ordered pairs, n, the position versus the value. So what we have in this is we have the first 5 terms, 1, 2, 3, 4, 5. And if we look at the beginning instructions, the terms are 4, 7, 10, 13, and 8, and 16. At points 1, 4, 2, 7, 3, 10, 4, 13, and 5, 16, I'm asked to make an observation. What do I notice? What I notice is that they lie on a straight path. This is student page 3. We're still on lesson 1, module 3, and because this is just hideous, I choose to ignore this problem, and you may too. We're not going to suffer. But we're going to look at this next one. Consider the sequence below that follows a -5 pattern. So each time we step up a term, we subtract 5. It says write a formula for the nth term of the sequence. Be sure to specify what value of n your formula starts with. Well, this is kind of interesting. So we're looking for the formula. So we want the function of n. And our first term is 30, and we're subtracting 5. Then if we think about it, we could say that the formula started at 35, and each time we step up a number, we subtract 5. So that's one way to think about this sequence. And if we do this, then we can start with n equals 1. And if we put in 1, we get the first term, f of 1 is 35 minus 5. 35 minus 5 times 1, which is 30. And that's the answer we're looking for. We could check, well, let's make this f of 3. And the third term, 1, 2, 3, we're expecting a 20. So the term should be 35 minus 5 times 3. And let's see what we get. 5 times 3 is 15. So we have 35 minus 15. And we get the f of 3, the function of 3. The third position is 20, which is exactly what it was. So we're pretty happy. Using the formula, find the 20th term of this sequence. All right, well, we're going to do the same thing we've been doing. F of 20 is going to equal 35 minus 5 times the value of n we've chosen for this one, which is 20. And we get equals 35 minus 100. So we can conclude that f of 20 is negative 65. That seems reasonable. We're going down by 10. If we're going to do it 20 times, we're going to... So we like this answer. It's a reasonable choice. We're going to graph the sequence of ordered pairs. Again, we're going to talk about position, first, second, third, fourth, fifth, to whatever number of terms, and the value of that term. We see that the first term is 30, and we subtract 5, 25, and we subtract 5, 20. Subtracting 5, 15, subtract 5, 10, 5, and 0. I could even go one more, negative 5, just to show you where it goes. Why not? 9 will give us, what, a negative 10. All right, let's go ahead and graph those dots. And we can see we have a lovely straight path shaping up. 6 is at 5, 7 is at 0, 8 is at negative 5. And 9 is at negative 10. Very nice looking.